Could it be that the greatest engineering achievements on Earth are not visions of the future, but realities already standing among us, quietly redefining what we think is possible? In Canada, the CN Tower dominates Toronto as a purpose-built communication structure, engineered to transmit broadcast signals across vast distances while enduring extreme winds and structural stress through precise, calculated design. In the Netherlands, the Delta Works operate as a national flood defense system, protecting a country with nearly 1/3 of its land below sea level, shielding millions from recurring storm surges and floods, and earning recognition as one of the 7 wonders of the modern world. In Pakistan, the Karakoram Highway stretches for over 1,300 kilometers through high-altitude passes, glaciers, and seismic zones, making it one of the longest and most dangerous paved roads ever constructed in mountainous terrain. What does it take to build higher than fear? What does it take to hold back the sea itself? What does it take to force a road through mountains that refuse to yield? These are mega projects that challenge physics, geography, and the edges of our collective imagination. In the moments ahead, stay with us as we travel through cities, coastlines, and mountain corridors to uncover how humanity continues to push beyond what once seemed impossible. In Dubai. Rising from the artificial shoreline of Blue Waters Island, this colossal observation wheel stands like a moving monument, redefining how scale, leisure, and engineering intersect in the modern desert city. Standing at 820 feet, it is the tallest observation wheel ever built, towering above every previous structure of its kind and lifting passengers higher than many city skyscrapers. From its highest point, visibility can extend several dozen miles, offering a rare panoramic alignment where the Burj Khalifa, Palm Jumeirah, and the curve of the Persian Gulf appear within a single, continuous rotation. To achieve this height, engineers used more steel than the Eiffel Tower, designing the structure to withstand constant coastal winds, salt corrosion, and desert temperatures that can exceed 110 degrees Fahrenheit. The cabins themselves are closer in size to private lounges than amusement rides, built to remain stable at extreme height while carrying passengers through a full rotation lasting nearly 38 minutes. It reflects Dubai's broader ambition to transform entertainment engineering into a global statement, proving that even leisure structures can operate at the frontier of material science, visibility, and urban scale. The Interlace, Singapore, reimagines high-density housing not as a vertical race toward the sky, but as a layered landscape where architecture spreads, overlaps, and breathes. The development is composed of 31 blocks, each rising about 6 stories, stacked and interwoven in a repeating hexagonal pattern that resembles a colossal game of structural blocks frozen in motion. Instead of isolating residents inside solitary towers, this configuration creates a continuous network of open courtyards, sky gardens, and shared terraces that encourage airflow, daylight, and social interaction across the entire complex. Built on a site of more than 8 acres, the project deliberately dedicates a majority of its footprint to greenery, water features, and communal spaces, allowing vegetation to function as both climate control and social infrastructure. By breaking the conventional vertical apartment model, the design improves cross-ventilation and reduces heat accumulation, a critical adaptation to Singapore's equatorial climate, where humidity and temperature remain high year-round. Awarded World Building of the Year, the project demonstrates how urban housing can combine density, environmental performance, and community life, revealing a new scientific and architectural logic behind collective living. Karakoram Highway, Pakistan, is carved into some of the most unforgiving terrain on Earth, standing as a living record of how far engineering can be pushed before nature begins to push back. Stretching for nearly 800 miles, this mountain artery links Pakistan with western China, threading its way through cliffs that drop straight into river gorges and slopes that never truly stop moving. At its highest point near the Kunjarab Pass, the road climbs above 15,400 feet, where thin air robs engines of power, slows human reaction time, and turns every repair into a physiological challenge as much as a technical one. The highway crosses a rare geological crossroads where the Karakoram, the Himalaya, and the Hindu Kush collide, concentrating earthquakes, avalanches, and landslides into a single corridor. Construction crews blasted directly into solid rock above the Indus River, often working from ropes and temporary platforms as water thundered hundreds of feet below. Over the decades, more than 1,000 workers lost their lives, most to falling rock, collapsing slopes, and extreme weather, making the road as much a human story as an engineering one. Today, the Karakoram Highway functions not only as a strategic trade route, but as a scientific case study in high-altitude construction, where geology, climate, and human endurance meet, proving that infrastructure can exist even in landscapes that seem fundamentally opposed to permanence. Cao Zhu Yin Yuan. Rising from the dense fabric of Taipei, Tao Zhu Yin Yuan feels less like a residential tower and more like a living experiment in ecological design, a structure where architecture, biology, and urban survival intersect. Often called the DNA Tower, this twisting landmark climbs to 370 feet, with each floor rotating subtly around a central core, creating a total spiral of nearly 90 degrees from base to crown. Its facade operates as a vertical ecosystem, wrapped in tens of thousands of trees, shrubs, and plants carefully selected to absorb carbon dioxide, trap airborne particles, and reduce surrounding temperatures during Taipei's humid summers. Environmental engineers estimate this living skin can offset several hundred tons of carbon emissions over its lifetime, turning a residential building into an active climate tool rather than a passive consumer of energy. Tao Zhu Yin Yuan reflects a new architectural philosophy, one where high-rise living behaves less like stacked concrete and more like a forest lifted into the sky, offering a glimpse of how future cities may grow in balance with the planet rather than in opposition to it. Chengdu SKP redefines the idea of a luxury mall by sinking much of its vast commercial program beneath the city, turning retail into an underground metropolis rather than a towering landmark. The complex spans more than 5 million square feet of total floor area, with the majority of its shopping spaces hidden below ground to reduce visual impact and preserve Chengdu's urban skyline. Above the surface, landscape parks, water features, and pedestrian paths stretch across the site, creating the impression of a public ecological zone instead of a dense commercial block. This inverted design uses Earth itself as insulation, stabilizing indoor temperatures and cutting energy demand in a subtropical climate where summer heat and humidity can push cooling systems to their limits. Natural light is funneled underground through large atriums and reflective surfaces, allowing daylight to penetrate multiple levels without relying solely on artificial illumination. The layout mirrors an underground city with layered circulation routes that separate foot traffic, logistics, and services, reducing congestion while maximizing usable retail space. As one of the most high-end shopping destinations in China, it attracts global luxury brands while quietly demonstrating how architecture, climate science, and urban planning can merge commerce with sustainability. Siduhe Bridge. Stretching across a remote valley in Hubei province, this suspension bridge spans a landscape where depth, isolation, and weather once made permanent crossings nearly unthinkable. The roadway hangs about 1,640 feet above the valley floor, placing it among the highest bridges ever constructed and briefly earning it the title of the world's tallest bridge at the time of completion. With a total length approaching 4,000 feet, the suspension span links two sheer cliff faces, floating across open space where conventional ground access was almost non-existent. During construction, materials and equipment were transported by aerial cable systems, while crews worked in conditions dominated by strong winds and persistent fog that could reduce visibility to just a few dozen feet. By conquering such vertical terrain, the project transformed travel routes through central China, replacing long detours with a direct crossing suspended high above the landscape. More importantly, it became a technical turning point, proving that modern suspension bridge engineering could safely occupy the deepest voids of mountainous geography and paving the way for an entire generation of record-breaking canyon bridges that followed. Eden Project. Rising from the scar of a former clay mine in Cornwall, this vast ecological complex transforms an industrial void into a living laboratory where ecology, climate science, and engineering intersect. The site is defined by enormous biomes, reaching roughly 180 feet in height and spreading across more than 30 acres. Their inflated geometry designed to contain full-scale simulations of Earth's major ecosystems. Each dome is constructed from lightweight ETFE panels, a material far thinner than glass, yet strong enough to resist Atlantic winds, allowing maximum sunlight to enter while retaining heat with high efficiency. Once the largest greenhouse system in the world, the enclosed rainforest maintains temperature and humidity levels that mirror climates located thousands of miles from the United Kingdom. Inside, several thousand plant species from tropical and Mediterranean regions grow side by side, offering a rare opportunity to study how vegetation responds when removed from its native latitude. The surrounding terrain remains visibly scarred, emphasizing the transformation from industrial extraction to ecological renewal. More than a visitor attraction, the project demonstrates how degraded landscapes can be converted into long-term platforms for environmental education, sustainability research, and climate awareness. Ping and Finance Center rises above the fast-evolving skyline of Shenzhen, signaling the arrival of a new financial core where architecture becomes a direct expression of economic momentum. The tower climbs to roughly 1,965 feet, placing it among the tallest buildings ever constructed and forcing engineers to confront wind behavior that intensifies dramatically at extreme altitude. Its tapered form is not aesthetic alone, but aerodynamic, reducing vortex shedding and lateral sway as seasonal typhoon winds sweep across the Pearl River Delta. The exterior combines stainless steel and glass into a seamless skin designed to resist corrosion, temperature fluctuation, and long-term structural fatigue in a dense coastal megacity. Early plans included a taller antenna, but airspace restrictions near a major international airport required its removal, subtly reshaping the final height while revealing how aviation and architecture now compete for vertical territory. Inside, the structure operates as a vertical city, stacking offices, a high-rise hotel, and a public observation deck where visibility can extend dozens of miles on clear days. More than a record-setting tower, the building reflects how 21st-century Chinese megacities fuse engineering, finance, and urban identity into a single upward statement. Delta Works stands as one of the most ambitious flood defense systems ever engineered, stretching along a coastline where water has shaped history as much as land. Extending more than 20 miles, this vast network of dams, dikes, storm surge barriers, and movable gates was conceived after the catastrophic North Sea flood of 1953, an event that reshaped Dutch thinking about survival, planning, and time. In a country where nearly 1/3 of the land lies below sea level and about 2/3 faces regular flood risk, the project was designed not for ordinary storms, but for events with odds as rare as 1 in 10,000 years. Its most famous element, the Oosterschelde barrier, introduced a radical idea: massive gates that can close during extreme storms, yet remain open under normal conditions, preserving tidal flow and protecting fragile marine ecosystems. Construction unfolded over 4 decades, demanding long-term political commitment and scientific forecasting that extended far beyond a single generation. Recognized as one of the 7 wonders of the modern world, the Delta Works reflects a uniquely Dutch philosophy, not of conquering water, but of mastering coexistence through precision, patience, and engineering built to last centuries rather than years. Huajiang Bridge rises across the sheer walls of the Huajiang Grand Canyon in Guizhou Province, standing as the highest canyon crossing bridge ever built in a landscape where vertical rock and drifting cloud often erase the horizon. The roadway floats more than 2,000 feet above the canyon floor, placing vehicles at an altitude where temperature shifts, air pressure changes, and wind behavior feel closer to low-altitude flight than ordinary highway travel. Designed as an ultra-long-span suspension bridge, the structure removes the need for central piers, allowing engineers to leap across near vertical cliffs that once made conventional bridge construction impossible. During construction, crews worked inside dense fog that can blanket the canyon for over 200 days each year, forcing reliance on sensors, satellite positioning, and digital modeling instead of direct line of sight. Completed in 2025, the bridge shortened travel across this fractured terrain from hours of winding mountain roads to just a few minutes, fundamentally changing regional mobility and emergency response. Beyond transportation, the structure demonstrates how modern bridge engineering transforms extreme geography into functional infrastructure, redefining how height, weather, and isolation can be overcome through precision design. Turning Torso rises along the Baltic shoreline of Malmö like a frozen motion, a skyscraper that appears to twist its own anatomy against gravity. The tower reaches approximately 623 feet, composed of 9 stacked cubic segments, each rotated incrementally around a reinforced concrete core to produce a total twist of nearly 90 degrees from base to summit. This rotation is not decorative illusion, but structural reality, requiring complex load calculations to redirect wind forces that intensify over open water and flat coastal terrain. Inspired by the human body in motion, the design transforms architecture into inhabitable sculpture, where steel exoskeletons and post-tension concrete work together to stabilize a constantly shifting geometry. When completed, it became the tallest building in Northern Europe, signaling Malmö's transformation from an industrial port into a hub of design, innovation, and cultural reinvention. Construction was marked by major cost overruns and national debate, exposing the tension between experimental architecture and public investment in Sweden's welfare-oriented society. Today, the tower stands as a case study in how advanced structural engineering can translate abstract form into physical reality, reshaping skylines and redefining what a skyscraper is allowed to look like. Lingshan Escalator. Climbing the steep flank of Mount Lingshan, This outdoor escalator system transforms a once exhausting ascent into a seamless journey through one of China's most revered spiritual landscapes. Built as a continuous series of open-air escalator segments, the system lifts visitors by hundreds of feet, bypassing slopes that previously required long climbs up stone steps carved directly into rock. Installed on a rugged mountainside, the structure had to adapt to uneven bedrock, persistent humidity, and seasonal rainfall, conditions that rapidly accelerate corrosion and mechanical fatigue. At peak periods, the escalators carry millions of visitors each year, redistributing foot traffic and reducing erosion caused by mass pilgrimage along narrow mountain paths. For elderly visitors and those with limited mobility, this infrastructure opened access to areas that were once nearly unreachable. More than a transport solution, it demonstrates how modern engineering can merge with geography and tradition, allowing contemporary infrastructure to support ancient belief without erasing its sense of place. Lotte World Tower. Rising above the dense urban fabric of Seoul, this skyscraper reshapes the city's skyline and its sense of vertical possibility. Completed after nearly 6 years of construction, the tower reaches approximately 1,819 feet into the atmosphere, making it the tallest structure ever built in South Korea. Its slender profile was inspired by traditional Korean ceramics and calligraphy, translating cultural heritage into a form that appears almost weightless against the sky. Inside, 123 floors are stacked with precision, housing offices, luxury residences, a hotel, and one of the world's highest observation decks, where visitors look down on a city of more than 10 million people. From an engineering perspective, the building was designed to endure seismic forces and extreme winds, a rare requirement in a region where super-tall towers were once considered impractical. Before opening, the structure underwent thousands of safety tests, reflecting intense public debate over risk, scale, and urban impact. Today, the tower stands as a scientific and architectural statement, signaling Seoul's ambition to compete with global megacities while anchoring futuristic design in centuries-old tradition. Urasun Bridge. Stretching across cold northern waters, this remarkable link quietly rewrote the geography of Scandinavia. What begins as a sweeping bridge longer than 5 miles carries both trains and cars above the Baltic, uniting Copenhagen and Malmö in a single daily commute. Then, almost unexpectedly, the roadway descends and disappears beneath the sea, transforming into a tunnel to protect flight paths leading into Copenhagen Airport. This transition happens on Peberholm, an artificial island formed entirely from excavated seabed material, where nature took control without human planning. Over time, hundreds of plant species and nesting birds colonize the island, turning a byproduct of engineering into a living ecological laboratory. Each day, tens of thousands of people cross an international border almost without noticing, reshaping labor markets, housing patterns, and cultural exchange. More than infrastructure, this connection demonstrates how modern engineering can dissolve national boundaries, merging two countries into one shared urban rhythm guided by physics, planning, and imagination. Yaxi Expressway. High above the mountains of southwestern China, a ribbon of asphalt floats through mist and cloud, challenging gravity and geography at the same time. This mountain expressway stretches roughly 140 miles, yet more than half of its length is suspended on bridges or carved through tunnels, threading across deep valleys and fractured rock. Engineers had to confront landslides, intense rainfall, seismic activity, and near-constant fog, conditions that demanded safety standards far beyond ordinary highways. Some bridge decks rise thousands of feet above the valley floor, where temperature shifts and high winds test steel and concrete every day. To manage these extremes, sensors monitor structural stress in real time, while advanced drainage systems channel monsoon rains away from unstable slopes. Before this road existed, crossing the region could take several hours of slow, hazardous mountain driving. Now, travel time has been cut by more than half, transforming trade, tourism, and emergency access for remote communities. Beyond transportation, this expressway stands as a scientific experiment on how modern infrastructure can coexist with extreme terrain, proving that even the most unforgiving landscapes can be connected when engineering meets ambition. King Abdulaziz Center for World Culture. Rising from the site of Saudi Arabia's first commercial oil well, the King Abdulaziz Center for World Culture stands as a quiet pivot point between extraction and imagination. Often called Ithra, the complex appears less like a building and more like a geological event, its sculpted forms echoing stones shaped by desert wind over thousands of years. The tallest volumes reach roughly 300 feet, wrapped in tens of thousands of stainless steel panels, engineered to reflect heat while surviving sandstorms and extreme temperature swings. Rather than relying on rigid geometry, the structure uses continuously curved surfaces, demanding advanced digital modeling and custom fabrication at a scale rarely attempted in cultural architecture. Inside, the program unfolds like a miniature city, combining museums, archives, a library, theaters, and science exhibition halls under one roof. Some interior spans exceed 100 feet without visible columns, requiring hidden structural ribs that behave more like aircraft frames than conventional beams. Placed deliberately on historic ground, the project transforms a landscape once defined by oil output into a center focused on knowledge circulation. It signals a national shift, where cultural infrastructure becomes a long-term investment in science, creativity, and global dialogue rather than raw resources alone. Nanjing Xifeng Tower. Rising above the historic core of eastern China, Nanjing Xifeng Tower reshapes the skyline of a city better known for ancient walls and imperial legacy than glass and steel. When it was completed, the tower briefly ranked among the world's 10 tallest buildings, signaling Nanjing's arrival in the era of global financial architecture. The structure climbs to roughly 1,560 feet, a height where wind becomes a dominant force, shaping every engineering decision embedded in its slender profile. Vertical grooves carved into the facade are not decorative gestures, but aerodynamic channels, designed to disrupt wind vortices that can destabilize super-tall buildings. The tower's form draws inspiration from nearby Mount Xifeng, translating natural contours into a modern silhouette that links geology with urban ambition. At upper levels, a public observation deck opens views across a city layered with more than 2,000 years of recorded history, compressing dynasties into a single horizon. Structurally, the building relies on a hybrid system of reinforced concrete and steel, calibrated for dense urban soils and seismic considerations. More than a vertical landmark, the tower marks a shift in identity, where historical capital evolves into a contemporary center of commerce, technology, and vertical urban life. National Museum of Qatar. Rising from the heart of Doha, the National Museum of Qatar unfolds like a geological event frozen in motion. Its form inspired by the desert rose crystals that grow slowly beneath extreme heat and pressure. The structure is composed of hundreds of interlocking architectural discs, some reaching diameters of over 200 feet, creating a building almost entirely free of conventional vertical walls. These tilted discs intersect at precise angles, forming a self-supporting system that challenged both digital modeling and on-site construction at an unprecedented scale. At the core of the complex sits the restored palace of Sheikh Abdullah bin Jassim Al Thani, allowing visitors to physically walk through Qatar's past while surrounded by a radically modern shell. Inside, galleries flow without clear linear paths, mirroring the non-linear history of a nation shaped by nomadic life, pearl diving, and the sudden arrival of energy wealth. Rather than towering upward, the museum spreads horizontally across more than 350,000 square feet, anchoring itself to the land instead of dominating the skyline. This approach transforms architecture into narrative, where science, geology, and cultural memory converge to tell the story of a nation emerging from sand into global relevance. Guangzhou Opera House rises along the Pearl River like a geological formation shaped by water and time, redefining how a performance space can belong to its landscape. Designed by Zaha Hadid, the structure is composed of two asymmetrical volumes that resemble river stones, suggesting motion even when the building stands still. The complex spans more than 70,000 square meters, making it one of the largest cultural venues ever built in southern China. Its exterior abandons right angles almost entirely, replacing them with fractured geometries that required advanced digital modeling long before construction could begin. The facade is assembled from tens of thousands of unique stone and glass panels, each custom fabricated to fit a precise position on the curved surface. No two panels are identical, turning the building into a massive three-dimensional equation solved through parametric design and computer-controlled manufacturing. During construction, tolerances were measured in millimeters, as even minor deviations could disrupt the flow of the entire surface. Inside, the main auditorium seats over 1,800 people, engineered to deliver acoustic precision despite the unconventional geometry. Rather than isolating art from the city, the Opera House acts as an extension of the riverbank, blending performance, engineering, and urban geography into a single continuous form. Landwasser Viaduct curves through the alpine air like a frozen wave of stone, carrying trains across the Landwasser Valley with a confidence that feels almost impossible for its era. Completed in the early 20th century, the limestone bridge rises nearly 200 feet above the valley floor and stretches close to 450 feet in length, all built from stone and mortar without reinforced steel. Its elegant curve was not a stylistic choice, but a geographic necessity, shaped by the narrow valley and unstable mountain slopes of the Swiss Alps. Moments after a train leaves the viaduct, the tracks plunge directly into a tunnel carved straight into solid rock, creating a seamless transition from open air to mountain interior. This dramatic alignment required surveying precision at a time when calculations were done by hand, long before digital modeling existed. Construction took place in harsh alpine conditions, where snow, wind, and altitude shortened working seasons and limited access to heavy machinery. The bridge has endured more than 100 years of freeze-thaw cycles, avalanches, and vibration from passing trains, yet remains structurally sound. The viaduct stands today as a lesson in how geography, material science, and human ingenuity can converge to create infrastructure that feels both fragile and eternal. The Opus in Dubai stands as a rare architectural paradox, a solid cube carved open by an absence that becomes the building's true centerpiece. Designed by Zaha Hadid, the structure rises roughly 300 feet, its outer form appearing calm and monolithic, while the interior void twists and melts as if shaped by invisible currents of air. This central opening is not decorative but structural, demanding complex load redistribution so the surrounding mass could span an empty space suspended high above the ground. During daylight, the dark glass skin mirrors the desert sky and surrounding towers, reducing solar glare while masking the building's true depth. At night, the void ignites with light, transforming the hollow core into a glowing urban sculpture visible across the Business Bay district. Inside, the building blends hotel spaces, offices, and galleries into a single continuous volume rather than stacked floors, challenging conventional vertical zoning. Advanced parametric modeling was required to fabricate the curved glass panels, many of which are unique in shape and orientation. The design responds to extreme desert heat, where summer temperatures can exceed 110 degrees Fahrenheit by integrating shading geometry directly into the form. It reflects Dubai's ambition to turn architecture into a cultural signal, where engineering precision and visual drama operate as one uninterrupted experience. Chongqing Grand Theater. Rising along the Yangtze River, this massive cultural complex anchors the opposite bank of Chongqing's dense urban core, turning the waterway into a theatrical stage for the city itself. Its bold geometry evokes a colossal vessel moored at the shoreline, a deliberate reference to Chongqing's long history as an inland river port where ships once carried trade deep into China's interior. At night, the reflective exterior captures and scatters city lights across the river, transforming moving water into part of the performance. Inside, the main auditorium seats more than 1,000 spectators, engineered to support opera, symphonic concerts, and large-scale productions without acoustic compromise. The hall serves one of the most populous metropolitan regions on Earth, where tens of millions of residents generate constant demand for public cultural space. Built on a narrow river peninsula, the structure had to withstand seasonal flooding, fluctuating water levels, and heavy river traffic passing only a short distance away. Beyond performance, the theater functions as an urban landmark, helping shift Chongqing's identity from industrial river hub to cultural capital. It demonstrates how large-scale architecture can redefine a waterfront, using art, engineering, and geography to recast how a megacity presents itself to the world.